Hey guys, welcome to this stage with me. This feels really, I feel like I should sing a song or something. Yeah, I'm not going to. You don't want me to. All right, cool. So today we're going to be talking about beyond Liveview, building some real-time features with Liveview, PubSub, presence, and a new-ish thing called Liveview hooks. First, I'm going to reintroduce myself. So thank you, Brian. So hey guys, I'm Sophie. This is my dog. His name is Moby. He's really cute. There are a few pictures of him in today's slide deck, so please get ready. As Brian said, I'm an engineer and a sometimes teacher at the Flatiron School, and I'm also a contributor to Elixir School, which is a free open source Elixir curriculum. We always want lessons. We always want blog posts from contributors, new and old. So if you haven't come across it yet, check it out and write something for us. Okay, plug done. Actually, one more plug. I do want to kind of just give a shout out to my own team at the Flatiron School, without whom I certainly couldn't have done this or really learned so many of the things that I have learned in the past couple of months and years. So yeah, just shout out to those guys as well. Okay, so I want to begin just by taking a look at the roadmap for today's talk. 3 basic sections. First, we'll be taking a peek behind the scenes at some Liveview source code to demonstrate that Liveview can, in fact, do just about anything because of the manner in which it wraps Phoenix channels. Then we're actually going to make our very own Liveview do just about anything by extending its functionality with the help of PubSub, presence. And lastly, we're going to be wowed, definitely wowed, by Liveview's JavaScript interoperability functionality. And then we'll be a little less wowed, but still very impressed when we take a look, once again, under the hood at some Liveview source code, this time on the front end. So yes, Liveview does mean that you don't have to write a lot of JavaScript, but today I'm going to make you look at some of it, just some of it. Okay, so I want to jump into our first topic, Liveview and Phoenix channels. Liveview, just channels in disguise. So it's definitely an oversimplification to say that Liveview is just channels in disguise. Liveview obviously provides so much more functionality than channels already offer us. But the features we'll be looking at today, I do want to zero in on the part of Liveview that really is a wrapper around channels. This is the functionality that allows Liveview to transcend some of its seeming limits. All right, so why do we care that Liveview leverages Phoenix channels? We already know that Liveview is objectively great. Studies have shown this. 4 out of 5 doctors agree. It's given us the ability to implement flexible and responsive UIs almost entirely with server-side code and really not that many lines of server-side code on top of that. We can build things like complex games. We can handle things like form validations, autocomplete, user notifications. If anybody checked out like the Phoenix Frenzy competition submissions, you know that the things you can do with Liveview are varied and very cool. And we can back all of these cool features with the concurrency and fault tolerance of Elixir processes. But Liveview has limits, or at least it seems to. So I think as we use Liveview for more and more real-time features, we're going to want to naturally reach for the other real-time functionality that Phoenix has promised us. For example, user tracking and message broadcasting. So something like a chat app, which is like the traditional Phoenix channels example, therefore not a good candidate for Liveview. If we're building out a set of features that requires user tracking and broadcasted updates, would we eschew Liveview and just go back to using channels? Would we do something like incorporating Liveview into a page that's like already backed by these other technologies? You can probably guess the answer to this question is no. Liveview can do a lot more. And the reason why is that it's really just a process. And like any process, we can teach it to send and receive certain messages. But what do we mean when we say that Liveview is just a process? I read that a lot, like in the documentation and in a lot of the articles and blog posts that came out about Liveview. Liveview is a process. It's just a process. And I wanted to understand where the process is in all of that kind of Liveview component source code. So the Liveview documentation states that Liveview is built on top of channels. And in fact, when your app renders a Liveview channel is joined, and this is the channel that receives messages and actually calls out to the Liveview module that you would define. So I want to take a closer look at how this works. We're going to take a look at some Liveview under the hood. Also, I do not recommend letting my dog repair your car. This picture is not a reflection of real life. All right, so let's say we have a Liveview backing our chat apps show page, which is exactly what we'll be doing later on today. Let's take a look at the procedure that occurs when a user visits a chat room at the chat/ID route. the first thing that we would do is invoke Liveview controller's live render 3 function with something like the following snippet of code. So you would have this in like the show action of our own app's chat controller. We're calling Liveview controller live render 3. And I want to call attention to the fact that the second argument that we're giving to live render is the Liveview module that we would have or will have defined. So this call to live render 3 is what kicks off the Liveview lifecycle. Before we look under the hood at the live render function though, I just want to do a little announcement. So the code that we're about to look at is not code that you would have to write in your very own Liveview to get things up and running. The whole point of Liveview is that you don't have to write this kind of code anymore. I just want to draw a distinction between this would be like the one snippet that you would be on the hook for writing, let's say in your own controller action. Everything that's coming up is source code. Okay, so Liveview controller's live render 3 function in turn calls Liveview static render 3. Once again, just passing through our Liveview module, which if you recall is chat Liveview, a Liveview module that we would have defined. Liveview static render 3 is really where the magic happened. It configures the socket with our app's endpoint and, you guessed it, our actual Liveview module. The static HTML template is then rendered, which fires the Liveview socket connect request. The socket, which remember has already been configured to know your Liveview module for this particular lifecycle, is also configured to route Liveview events to the Phoenix Liveview channel. And once the socket is connected, the client will send that channel join request. And here's just a little peek at some very simplified Liveview client-side code. We can see that it's establishing a channel for the given Liveview with like a unique topic, and then we're going to join the channel via a call to channel join. So this starts the Liveview channel process where that channel's socket knows its corresponding Liveview module name, since the socket, once again, was configured with this way back when we static rendered. So later, when the client sends an event up that Liveview channel, the Liveview channel is going to look up the Liveview module from its socket and invoke functions on that module. And once again, a very simplified look at some Liveview source code. This is the Liveview channel. We can see that when the channel receives a message from the client, it's going to look up the Liveview module from the socket and really just call handle event 3 on it, passing in the event name, the event value, and the socket itself. So Liveview, at least in this sense, is a wrapper around Phoenix channels, and it exposes an API that abstracts away a lot of the repetitive setup and a lot of the JavaScript that channels leaves us on the hook, that's a pun for later, for writing. So if you kind of think back to some of the source code that we just peeked at, it probably feels really familiar to you from having worked with channels yourself. You're familiar with like setting up your socket, pairing it with a channel, writing some socket connect and channel join code on the front end, and writing some logic that handles events in the channel. So one of the really cool, nice things about Liveview is you don't have to do any of that at all, which is pretty cool. Okay, so now that we can see exactly how Liveview is built on top of channels, it probably won't surprise you that we can therefore use Liveview together really easily with Phoenix PubSub and Presence, and we can even hook into events that the channel sends down to the client in response to state changes on the back end, and we'll do that by leveraging Liveview hooks, which we'll take a look at later on. All right, so let's do it. In this talk, we're going to build a chat app entirely backed by a Supercharge Liveview. It's going to incorporate PubSub, Presence, and hooks to give us all the real-time functionality that any respectable chat app offers its users. Let's take a look at the features that our chat app needs to support. So we'll certainly have real-time messaging. Anytime a user submits a new message, everybody in the chat room should see it. We'll have some user tracking. We want a nice little list of everybody who's present in a given chat room. And we definitely need to have a responsive UI. Anytime a new message shows up in the chat, we want our chat window to scroll down so that everybody can see it. Pretty standard stuff. Okay, so to revisit our roadmap, the first of these two features brings us to our second topic on the roadmap, extending Liveview with PubSub and Presence. And we're going to begin with our very first feature, which is message broadcasting with PubSub. This is really like the most basic functionality that any chat app offers. If not everybody in the room can see new messages, it's like really not a chat app at all. So we're going to start by taking a look at what Liveview provides us out of the box, and then discuss why and how to implement message broadcasting from Liveview. All right, so we have a fresh out-of-the-box live view. Let's talk about how it enacts real-time updates for the single user represented by one live view process. So LiveView will receive a message when a user submits a new chat message. It will update its own state, and it will re-render its own LEEX template. We need to understand that this happens within the LiveView process belonging to the user that submitted that message only. And let's take a look at this from a UX point of view. Oh God, that's no good. So here is nice chat where I'm just casually talking about my dog's thoughts and feelings. And we can see that the new message showed up for me, and there's nothing here for the person that I'm chatting with. So we definitely need message broadcasting. This is no good. In other words, we need PubSub. This is the first point when I was building out this chat app that I kind of felt like I wanted to reach for Phoenix channels. But wouldn't it be nice if we could get our existing live view to simply broadcast updates to a set of subscribing clients? Shockingly, we can use PubSub to do exactly that. Just a note on what PubSub is. It's loosely described as a pattern in which you can publish messages to a topic so that those messages can be consumed by any client subscribing to that topic. And I also want to note that Phoenix's PubSub library takes advantage of distributed Elixir. So clients across distributed nodes of our app can subscribe to a shared topic and broadcast to that shared topic because PubSub can directly exchange notifications between servers when configured to use the PG2 adapter, which we'll take a brief look at a little later on. One gotcha, and I finally realized what was wrong with the live view feature that my team has in production this morning when I was reading this slide. You need to remember to configure the distributed nodes of your app to allow for communication between those nodes over whatever range of ports PubSub wants to use. So if, like me, you are totally stumped as to why PubSub seems to work sometimes in your production application, remember this. All right, so how will we use PubSub to make sure that all of the users in a given chat room can see any new messages? I want to break down the procedure that we're going to build out. So when a live view process starts up for a given user, we will subscribe it to that chat room's topic. Then when a user submits a new chat message, that live view will broadcast to all the other chat room subscribers, which are all the users in the chat room. The subscribers will receive the message and they will act to update their own live view process's state, which will cause their own templates to re-render. In this way, we are going to combine the real-time capability provided by LiveView with the ability to pass messages across a distributed set of clients provided by PubSub, a pretty powerful combination if you ask me. I want to start just by taking a brief look at our app's PubSub configuration. So you get this out of the box when you start a new Phoenix app. You don't have to write this config yourself, but we can see that our app's endpoint is configured with the Phoenix PubSub PG2 adapter. That way we'll be able to subscribe clients across the distributed nodes of our application, should we deploy it that way. And this configuration will ensure that the PubSub backend starts up with our app and exposes its functions via our app's endpoint module. All right, so I think we're ready to teach our clients to subscribe to a shared topic in the live view. When should a live view start subscribing to a chat room's topic? Really as soon as the process starts up, so we'll use the live view mount function to hook into this moment in time. Here's a simplified look at our mount function. We're subscribing to the chat room topic, which we've decided will be chat ID via the Phoenix PubSub subscribe 3 function, which again we have access to via our app's endpoint module. And now our live view processes will be subscribed to the chat room topic as soon as the live view mounts, and we're ready to start broadcasting. All right, broadcasting to a topic. So when should a given live view process broadcast a message? For our feature, in our case, it's as soon as a user submits that new chat message. So we're going to use LiveView's handle event callback to hook into this moment in time. Simplified look at our handle event function. When a user submits a new chat message, LiveView will call handle event 3. Here, what we're doing is we're updating the chat with a new message record, and then we're broadcasting this event to the chat room topic using the broadcast 3 function. All of the subscribing clients, all the other live views that are subscribed to this topic, will receive this message along with the payload describing the updated chat via a handle info function, which we'll look at now. Here's our handle info 2, and it's going to match an event type of new message. It's going to receive the payload describing the updated chat. All of these subscribers will update their own state via the assign function, which will cause their own templates to re-render, and everybody will see that new message appended to the page. Just a little overview with this extremely beautiful color-coordinated chart that I am extremely proud of. So in step 1, our user will submit a new chat message. In step 2, that user's live view process will update the chat and broadcast a message to all the subscribing clients. In step 3, all of the subscribers will consume that broadcast. Step 4, they'll update their own state and causing the template to re-render. Pretty cool. So what did this approach win us? The Phoenix PubSub library allowed us to build a real-time feature that broadcasts shared updates to a set of users with just really a few additional lines of code, like maybe 6 lines of code. It's pretty cool. Our Phoenix app was already configured to use PubSub. It already had the PubSub backend up and running, and so integrating it with our existing Liveview code was really pretty straightforward, and we had even more advanced real-time functionality up and running in no time, which brings us to our next feature. Now that our Liveview is smart enough to broadcast messages to all the users who are in the given chat room, I think we're ready to build a feature that actually tracks those users. So let's say we want our template to render a list of people who are in the chat room, something like this, in this handsome purple box. There's options here, right? We could create our own data structure for tracking user presence in a Liveview, store it in the Liveview socket, hand roll some function, maybe leveraging like an agent or something, to share this information across clients, build all our own functions to update that data structure when a user joins, leaves, or otherwise changes state, and then we could use PubSub ourselves to broadcast these changes. That sounds like a lot of work, and I really don't want to do it. It also sounds like exactly what Phoenix Presence does. So the Phoenix Presence behavior abstracts this work away from us. It provides presence tracking for processes, leveraging PubSub behind the scenes to broadcast updates. And it's also, I think, interesting to note that it uses a CRDT, which stands for, am I going to get this right, conflict-free replicated data type model, which means that it works with distributed applications. Pretty perfect. So unlike PubSub, you do have to configure presence yourself in your own application. So let's take a look at what that looks like now. We'll define a module called Chat Web Presence. It uses the presence behavior, and it specifies that it shares a PubSub server with the rest of the application. Now we can use the Chat Web Presence module throughout our app to track user presence in a given PubSub topic, and events that are broadcasted by presence will get broadcasted over our same PubSub server so other processes in our app can subscribe to it. Our presence module will maintain lists of present users in a given chat room by storing these users under our chat room topic, once again in this case chat::chat ID. So we've got presence set up. We know roughly the functionality that we're going for. I think the question to ask ourselves now is, when should we tell presence to start tracking a given user? And I think we can answer that question with a question, which is, at what point in time do we consider a user to be present in a chat room? And again, it's when the user mounts the live view. So we'll continue to hook into our mount function, again, simplified, just showing the relevant code. We'll hook into our LiveView's mount2 function to add the new user to presence's list of users in a given chat room. We're using the presence track4 function to track our LiveView process as a presence. We're adding the PID of the LiveView process to presence's data store, along with a payload describing the new user under our shared topic of chat::chat ID and a key of the user's ID. And having started to track this the presence processes, it's kind of a tongue twister, the presence processes state for the given topic will look something like this. So we got our user ID and then the metadata describing the users, in this case email and name. I don't know what that was. How can we ensure that the other LiveView processes representing users in the chat room become aware of the new user joining, though? It's great that we've added this user to presence data store, but the whole point is that everybody knows it and sees the users who are in the room. So when a user is tracked by presence via that call to presence track4, presence will first update the list of users for the given topic, and then it's going to broadcast a presence diff event. Recall that all of our LiveView processes use PubSub to subscribe to the chat room topic on mount. Since presence is tracking users under that same topic and sharing a PubSub server with the rest of our app, our subscribing LiveView processes will receive this presence diff broadcast from presence. So we can use the handling of this event to have each subscriber grab the latest list of users and render them on the template. Let's teach our LiveView how to handle that presence diff event. We'll define another handle info2 function in our LiveView. This time it'll listen for the event of a type of presence diff. our function needs to get the list of present users from the presence data store and add them to the Liveview socket state so that the template can re-render and reflect any newly joined users. So let's take a look at how we can fetch these users from presence. We'll use the presence list one function to retrieve a list of tracked presences and their metadata for our topic. And then we're just going to iterate over that metadata, pull out the list of usernames. Lastly, we need to update Liveview socket state with this list, which we do via socket assigns. We're adding a key of users with a value of this list of usernames. And calling assign triggers the Liveview's render function, so the template will re-render, this time with all of the users, including any newly joined users that triggered this presence diff event. So let's take a look at the template code to render those users now. Pretty straightforward. Having added a key of users to our Liveview socket assigns, we can access our list of users via the @users assignment and in the LEX template, and we can just iterate over them, render their first names. Pretty simple stuff. But wait, let's think about this for a second. The code we have so far will broadcast an event whenever a new user joins the chat room. That will cause all the subscribing Liveviews to grab the list of users from presence and render them. So what we've really described is people already in a chat room having to wait for a new user to join before any users are displayed. That's not a great feature, I think, to offer our users in our very fancy and sophisticated chat room app. So how can we display a list of present users as soon as someone joins? They should see that list when the template first renders for them. We need to be able to fetch presence for those new users who are joining. And once again, we're going to hook into that mount function of our Liveview to make sure that that happens. So in our mount function, we will also use presence list to grab the list of users, get their usernames from that metadata, and add them to socket assigns here so that they will see the list of users on the page as soon as it renders for them. Pretty great. So we've talked about a user joining and ensuring that everybody who's already present will see their list of users on the page update and reflect a newly joined user. We talked about ensuring that users who do join will see a list of people who are already there as soon as the template renders for them for the first time. The only thing we have left to discuss is what happens when a user leaves the chat room. How can we update present state and broadcast changes when a user pieces out from the chat? So recall that we're tracking presence for a given Liveview process via the presence track for function, where the first argument that we give to track for is the PID of the Liveview process. What happens to a Liveview process when the user navigates away from the chat show page? She asked rhetorically. It dies. The Liveview process terminates, as I'm sure many of you guessed. This will cause the presence untrack3 function to get called, thereby untracking the terminated PID, which will in turn tell presence to remove the list of users from that user from the list of users for the chat room topic. And once again, for free, it will broadcast the presence diff event for you. Subscribing Liveview processes representing users who are still in the chat room already know how to handle that presence diff event. They're going to fetch the list of users from the presence data store. That list will no longer include the departed user. They'll update their own socket assigns, and the template will re-render without the person that left. Pretty cool. So in other words, in order to handle what happens when a user leaves, you have to do exactly nothing, which is awesome. I love having to do nothing. All right, so before we move on, I just want to briefly touch on some of the other things that this powerful combination of presence and Liveview can do for you. Now that presence is fully integrated with our Liveview, you could really imagine using it to do a lot more than just tracking whether or not a user is present. You can use it to do things with the state of that given user. So in our chat app, we could do things like allow a user to set their status to away, put some information on there about how long a user has been active or inactive for, indicate whether or not a certain user is typing, and so much more. So any such features would seamlessly integrate into our Liveview thanks to Liveview and Presence's shared PubSub server and topic. So Liveview, PubSub, and Presence all play together really nicely. And before we move on to the very last piece of our roadmap for today, I just want to take a step back and recap what we've built so far. So with our out-of-the-box Liveview, our chat had the ability to push real-time updates to only the user that initiated that change. So in other words, users who submit a new message via the chat form would see that new message appear and nobody else would. But with the addition of PubSub, we were able to broadcast these new chat messages to all of the Liveview clients subscribed to a given chat room's topic, everybody in the chat room. And then by leveraging presence, we were able to track and display the list of users present in a given chat room at any time. So the flexibility of PubSub made it really easy to subscribe all of our running Liveview processes to the same topic on the same PubSub server. In addition, Presence module's ability to share that PubSub server with the rest of our app allowed Presence to broadcast events to those same Liveview processes. So overall, Liveview, PubSub, and Presence really get along, and they've enabled us to build a really robust set of features with very little hand-rolled code, which, I don't know, we're all probably pretty lazy. I'm a fan. Okay, so this brings us to the last topic on today's roadmap, Liveview and JavaScript interoperability. By the way, I've been really paranoid that I'm going to mispronounce interoperability because it's kind of a tongue twister. So far I've nailed it 3 times, but there are more opportunities for me to mess this up. Okay, so Liveview and JS interop happens via a feature called Liveview hooks, and we're going to dive into this last topic via the last of the 3 features our chat app needs to implement, which is a responsive UI. Before we actually talk about this feature and how to implement it, I want to describe a problem that we have. Does this look okay to you guys? Looks terrible. In the current state of a world, when a new chat message is appended to the chat window, it appears just out of frame. This is a really terrible user experience, and even for someone like myself that doesn't spend a lot of time on the front end, I know that this is not okay, and no respectable PM would allow you to get this out the door. The chat window really needs to scroll down to accommodate and display new messages. Just keep talking. There we go. Nope. Cool. Fingers crossed. This is easy enough to do with just 1 or 2 lines of JavaScript. Even I know this. You would grab the height of the chat window and you would set the scroll top accordingly. What you really want to do, especially if you're familiar with Phoenix channels, you're going to find yourself reaching for something like this. You wish you could write just a little bit of code on the front end that listens for the arrival of those new chat messages, grabs the chat window, and adjusts the scroll top. That's what you want to do. You can't. You kind of can, and I'm going to talk a little bit about what you used to have to do to get something like this working up until very, very recently. So before the official release of Liveview, which I think came out at 0.30, I'm not sure, responding to a custom Liveview event on the front end was really not easy. The Liveview JavaScript offering did not expose a way for us to hook into specific diff events on the front end. All those diffs are calculated on the back end, which is one of the other awesome things about Liveview. You have that nice diffing engine and the server-side rendered HTML, but then down to the front end, it would really just push out a diff event, and you couldn't really do much with that. So the first version of this presentation that some of you may have seen at ElixirConf was created in that world, before the release of 0.30 and its introduction of Liveview JS interop. That left me writing a lot of really complicated, weird code. It was fun though. So in my original workaround, which I just want to touch briefly on, because I enjoyed it before I show you the easy way to do this, basically I set it up so that each Liveview process got its own accompanying sidecar channel, and I had the client join that channel over the same Liveview socket when Liveview first rendered the template. Later, when a user submitted a new chat message, I had the Liveview process send a message to its accompanying channel, which would in turn push a message down the socket to the client so that we could fire just that little snippet of scroll top adjustment JavaScript. And in order to get that working, I hijacked the Liveview socket source code, I augmented it with a custom channel, I had this whole complicated channel registry so that the Liveview could look up the PID of its associated channel, all of that so that I could basically just write this one line of scroll top equals scroll height. It was cool. It was actually really terrible and complicated. And as I was building the presentation the first time, I just thought I can't recommend that anyone ever do this. It's way too much work. And the good news is you don't ever have to do it. So wouldn't it be great if we could hook into Liveview events on the front end? After all, as we already saw by peeking at some source code, Liveview is just a channel, and channels do send events to the client. So, introducing, thank you, Chris McCord et al., Liveview hooks. What are they? So Liveview hooks are the interface for Liveview and JavaScript interop. Not even going to try. Interop is the new thing. It leverages JavaScript lifecycle callbacks to fire custom JS for particular Liveview events. And the events that we can hook into now are when an element is added, removed, or updated by the server. This is a full list of all of the events that you can hook into with Liveview hooks, but for our particular feature, our responsive UI for new chat messages, we really just care about the updated event when the element has been updated in the DOM by the server. In this case, when our chat window has been updated server-side by the addition of a new message. So by hooking into these callbacks, Liveview hooks allow you to do two things. You can fire custom JS, which is what we want. We want to adjust the scroll top of our window. And you can also manually push events back up to the Liveview process on the server. We're not going to be having much of a need to do that today, but you can, which is pretty cool. All right, so how does it work? Pretty simple setup. All you have to do is add a Phoenix hook binding to your DOM element, in which case the chat window whose scroll top we want to adjust. Here it is. Here's the messages chat window. We're adding this Phoenix hook that I've called new chat message. So now we have to go ahead and actually define the new chat message hook. Defining the hook object, we are establishing our hooks object, which is an empty object, adding a new hook, new chat message. Next up, we need to actually add that lifecycle callback. In our case, we want our new chat message hook to invoke the updated callback when the given DOM element is updated by Liveview. So what can our callback do? What kind of stuff can we do within this updated callback function? Couple things. The hook callback function exposes a handful of attributes that are in scope for you. You have the element, the actual bound DOM node. You have the view name, which is that DOM node's Phoenix view value. And then you also have access to this push event function, which is how you can push back up to the Liveview server side. We really are just going to leverage the element, our bound DOM node attribute today. So when our chat window is updated in the DOM, our updated callback will fire, and it's going to execute our scroll top adjustment code, which looks exactly like this. Pretty simple, pretty cool, pretty easy to use. The very last thing we need to do to get this all working is make sure that we pass our hook object to the socket. So we need to add this payload when we establish our Liveview socket. Before we connect, we pass in our hooks. And that's it. All right, so let's review. What's going to happen? A user will submit a new chat message. Liveview will receive that message and broadcast it to the subscribing clients. The subscribing Liveviews will consume that broadcast. They will update their own state via socket assigns and re-render their templates. The new chat message hook will fire. The updated callback function will be invoked, and it will set our new scroll top. And we're done. That's it. It just works, which is awesome. All right, so one more peek under the hood at some Liveview source code before we wrap up. Once again, reminder, don't let my dog under the hood of your car. All right, so hooks under the hood. The code underlying the hooks functionality has three basic parts. We're going to establish any hooks passed into our Liveview socket initialization via the Liveview constructor function. We're going to add any hooks to the DOM elements to which they're bound via that Phoenix hook binding. And lastly, we trigger the hook callback functions under the appropriate conditions. All right, establishing hooks in the constructor. Super, super simplified look at Liveview's live socket constructor function. We can see that this .hooks is set to the hooks object that we passed into our Liveview socket's initialization. So later, the hook callback functions we defined are mapped to the DOM elements that define Phoenix hook bindings. Again, very, very simplified version. We see that what's happening here is that we're looking up the Phoenix hook on the DOM element. If there are any, it's creating a new view hook instance that we can trigger the hooks callback so that we can trigger the hooks callback later under the right conditions. So the hook callback functions are invoked when a corresponding Liveview event is pushed down to the front-end client. When Phoenix Liveview invokes the update function upon receiving an update from the server, it's going to call the trigger hooks function, which I want to take a brief look at now. Again, very simplified, but essentially look up the hook for the given changed element and trigger the updated callback function. And last thing, I think it's the last thing, taking a look at view hook's trigger function. The trigger function simply looks up the callback function from that particular hook object and invokes it. It's pretty cool. It's easy to use. Even if you're like me and writing a lot of JavaScript is not your thing, it was pretty nice to be able to take a look under the hood and sort of see how all the pieces fit together. Okay, let's recap. We did it. My dog, again, he's really happy for us. We did a lot of things. So by integrating PubSub presence and hooks directly into our Liveview, we were able to support message broadcasting, user tracking, and a responsive UI, all of the features that support a rich real-time chat experience. So really, Liveview, it can do it all. The seeming limits that Liveview presented us when we were building out our chat application, we got over them, we got through them by incorporating available Phoenix real-time tools. Almost all of our chat functionality that we took a look at here is handled in less than 100 lines of Liveview code. And this is as opposed to all the channel, back, and front-end code that you would otherwise write. Again, if you think back to the first couple of slides of source code that we looked at for Phoenix Liveview, that's stuff that we were all having to write to set up our own channel implementation. We don't have to do that anymore. So using PubSub to do what PubSub is meant to do, which is broadcast and subscribe, it really doesn't feel like a misuse of Liveview. It feels like it fits together really nicely. And layering presence on top of that functionality also feels like a really good fit. And lastly, the recent introduction of Liveview hooks makes it super easy to implement any custom JS when you absolutely need to write your own JavaScript. That's it. Thank you. Yeah. You're welcome.
Hello. Can you hear me? Cool, okay. Thanks again, Sophie.
Yeah, no problem.
We have time for questions? Yeah. Okay, do we have any questions? Okay. Well, we still want to have the mic for recording.
One of the things that jumped out, I hadn't seen the new hooks API, but it's suspicious to me that they would include a push event function, so you could just like, hey, something updated in the DOM. Do you want to let the server know? I'm sure there are cases where that would make sense, but I couldn't think of any, and it would seem to beg a sort of like loop or sort of like event soup. And I'm curious, have you run into any use cases where you actually needed to push an event after a DOM update?
Yeah, that's a great question. So I was actually thinking the same thing. I feel like you could get stuck in almost like a recursion problem, not quite recursion, but yeah, this infinite loop of like, all right, let's say somebody clicked a button, I send an event to the server, server-side updates, I trigger an update callback, I push an event. It could be easy to play that a little bit wrong and then have that event trigger an update and push an event forever, which would be terrible. Yeah, I can't really think of a feature that would cause me to reach for that push event. Maybe, let's say, something on the front end needs to update in response to a server-side event, but like conditionally, maybe based on some other features on the page, conditionally pushing something back up.
Gotcha.
Yeah, so to answer your question, I have not reached for push event myself, and if anybody else has or can think of a good reason to, I'm certainly all ears.
Cool. Thank you.
Yeah.
Is if you have like geolocation or some kind of sensor type of thing on a browser that you want to push back, maybe? You got a question? Oh, I'm sorry. Any more questions? Okay. Thanks, Sophie.
Thank you. I forgot one shout out, which is these illustrations were provided by Miss Benny Wong, who's sitting right there.